Hi class, Mrs. Lowe here. I'm doing some homework problems from section 4.2, slope of a line, and this is going to be a two-part video. I'm going to do 6A and 11C on this video and 16A on a separate video. So this is on lesson 7, homework page 171, and I'm going to start with 6A. So 6A tells us to graph the line and write the equation in y equals mx plus b and find 2 more points on the line. So to provide a little more information, the line goes through point 0.03 and has a slope of 1. So when you graph a line, you always want to graph the point first, which is given, which is 0, 3. Now that also happens to be the y-intercept. So I do know that b in the formula y equals mx plus b is 3. So that helps me. Now I'm going to find another point on the line by simply counting the rise over the run. I know the slope has to be positive because there's no negative in front of the slope. I need to make this a fraction, so I'm going to put it 1 over 1, so I can rise 1 over 1. So I'm going to rise 1 over 1. Well, there's another point on the line. That's 1, 4, so that answers the other question, find 2 more points. And I can just continue in this fashion up 1 over 1, or I could go down 1 over to the left. But no matter if I go up or down, I need to run in order to keep the slope positive. And then draw my straight edge. My line with my straight edge and arrows on the end of your line. All of these integer points are points on the line, as are all the points in between these. But these are the easy ones to see. So 4, 7 is another point on the line. Negative 3, 0 is another point on the line. In fact, there's infinite number of points on this line. Now I have graphed the line. I've found at least 2 more points. I'm going to write it in y equals mx plus b. Well, that is easy because the slope is 1, and I know the y-intercept is b. So y equals x plus 3. Ta-da! All right, moving on to 11C. 11C says to find another point on the line. Well, if you're not sure how to start these problems, always start by graphing and then figuring out what you can find out about it. So -6, -2 is j right here, and k is 5, 8. And if I were to connect that, I have my line with my arrows on the end. Okay, and this is point J and this is point K. Well, I can't just guess and say, oh, that's a point on the line. That looks like -5, -1. The problem is you're guessing. Between every one of these points, you must have the same slope. So we need to know what JK is, the slope of JK. And if you count the rise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'll see that the rise is 10. That's your change in your Y values. And your run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Your run is 11. That's your change in X values. Well, as a slope, that's 10 over 11. That's a pretty, it doesn't break down, so I'm not going to be able to find an integer point between these two. But the easiest thing to do is to say, okay, if I go from K and I rise another 10 and I run another 11, where do I end up? Well, if I rise another 10, well, that would be the change in the Y values would go from 8 to 18. So if I rise, I would be at 18 up. And if I run, I would be 11 more, which would be 16. So 16, 18 would be another point, integer point on this line. Rise 10, and then run 11 would get you to 16, 18. Hope that helps.